Welcome to another exciting episode of AP Computer Science. Make sure you have your notebook and writing utensils handy. Java is a high-level programming language, and I know it's hard to believe it, but Visual Basic is another high-level language. High-level languages are similar to English than machine code. Programming in binary is considered low-level because ones and zeros look nothing like English or any normal human language. If you remember back to lesson 1, you'll remember there was a bit of code that drew a square. Although this program is very simple compared to what you'll code in the future, it illustrates the fundamental strategy of object-oriented programming. And here's the code from the last video, all on one whiteboard, as I learned how to space. The class is called drawSquare, and this class includes two methods. The first method, drawSquare, is named exactly as the same as the class, and is used in the construction for this instance of drawSquare. The second method is called draw. This is where most of the action takes place. The drawSquare constructor calls sketchpad's constructor to create a new sketchpad object named paper with an initial size of 30 by 30 pixels. Pencil is created using the drawing tool constructor that can be used in the 300 by 300 paper object. I've now essentially created this. The method draw only has the steps to draw a square. This program wouldn't work if I only had draw or drawSquare. They work in tandem together to create our perfect little square. But this program still won't actually run. I need to create a driver. This driver class is what actually runs the program. Right now it's not too terribly important for it to be a separate class, but when you work with multiple classes it allows the program to run relatively smoothly. I personally usually create the driver first. This way as I code I can test the program instead of waiting till the very end. The first few trial runs of any program usually end in crashing and burning, and the occasional error that nobody's seen before, which is always fun. So you have the beginning of a public class driver saying, hey, this is a class. The word static means that the driver always exists without an instance. You'll run into other static things later and even create your own, but today is not that day. Void means nothing is being returned, and I'll explain this in a bit. drawSquare means you're using the drawSquare class. SQ is a new instance of drawSquare. The SQ in the next line calls the draw method in the drawSquare class. After I get everything working, which usually takes time and patience and the occasional tears, I can take the drawSquare class and use it in other programs later on. Alright, time to move on to something a little more basic, and that is that many languages allow you to write comments. Comments are little miracles, especially when you write more complicated programs. They're used to write what a section does or what you're desperately trying to get it to do. This allows you to write multiple lines of comments. This lets you write a single line of comment, starting with the double slashes and ending at the end of the line. This is for Java docs. They can be one or multiple lines and are used to create APIs. I'll discuss Java docs and related jazz and theory in a different video. So, back in Comp Sci 1, you learned about the 3 virtues of a programmer: laziness, hubris, and impatience. Well, programmers don't reinvent the wheel each time they code because, well, that's work and we're lazy. They use something called packages, and Java's got a lot of packages. There are also many packages created by programmers that you can use. The import statement allows for the program to use these classes. The import statement looks something like this. The dot asterisk semicolon is very, very important. Every Java program contains a main method. However, not all classes need a main method, nor should they have one. If you don't set the parameters properly, things will crash and burn in epic proportions. Most classes will contain methods to define a class's behavior. A method has the following general syntax. Modifiers. Modifiers refer to a sequence of terms designating different kinds of access to the method using public or private. Method name. It's the name of the method. Return type. It's the type of data a method returns. You first learned about these in Comp Sci 1 and 2. Later we'll look at Java versions of int, double, char, void, and string in more detail. The draw method does not return a value, and therefore it's a void type. Parameters. Parameters lists will allow us to send values to a method. I have vaguely talked about this before in the draw example. Method body. It contains the statements that actually do the work. Every object must be declared. You can't just use a pencil you don't have, so you can't just use a variable you don't define. An object declaration designates the name of an object and the class to which the object belongs. And it looks a little something like this. Class name is the name of the class to which these objects belong. The object name is the name you decide on. In the case of draw square example, we decided the pencil object would be declared as drawing tool pencil. Another example using commas to declare objects. The first declaration declares an account object named checking. The second declares 3 customer objects, Bob, Betty, and Bill. I know like 30 seconds ago I made it sound like if you declare an object you have one. Well, no objects are actually created by the declaration. An object declaration simply declares the name or the identifier that we use to refer to an object. Calling a constructor using the new operative creates an object. The syntax for creating an object is object name, new, the class name, and then arguments. Object name is the name of the declared object. Class name is the name of the class to which the object belongs. Arguments is a sequence of 0 or more values passed to the constructor. In the draw square example, the paper object is created or instantiated with the statement paper equals new sketchpad 300, 300. After the object is created, I can start sending messages to it. The syntax for sending a message to an object is object name, period, method name. Object name is the name of the declared object. Method name is the name of the method of the object that you wish to use. Arguments is a sequence of 0 or more values passed in the method. In the draw square example, the pencil object is sent a sequence of messages. Forward with an argument of 100, and turn left with an argument of 90. So I want you to remember to the last time you took an art class. Could have been 2 hours ago or like 5 years. Either way, you learned how to draw. Well, drawings are helpful when designing software. A class diagram can be particularly useful. A class diagram shows the key features of a class like the class's name, attributes, and methods. Now let's dive a little bit deeper into what a class diagram actually is. As you already know, a class consists of attributes and methods. An attribute, or an instance variable, represents a property of the object. A method is an operation that can be performed to an object. It's useful to picture the attributes and methods. The class diagram follows the general form of a rectangle with 3 compartments separated by horizontal lines. The top section contains the name of the class. The middle section lists the attributes of the class, and the bottom section shows the class methods. This class notation is a part of the Unified Modeling Language, or UML. This is a diagram for the draw square class. The methods of the class are listed in the bottom compartment of the class diagram. One of the methods in Draw a Square class has the same name as the class. It may seem strange for a method to have the same name as its class, but this is how you give instructions on how to create objects of this class. The Draw a Square class also makes use of another class, Drawing Tool, the class of the pencil object. This class diagram for the class is this. This figure illustrates a couple of new notations that are typical for class diagrams. The ellipses shown within the class diagram indicates that a list of methods is incomplete. There are more methods in the Drawing Tool class that are not shown because they're not relevant to right now. UML diagrams frequently include labels within the double less than and double greater than symbols to categorize the class methods. The Drawing Tool method is categorized as a constructor method, while down, forward, and turn left are modifier methods. The distinction between constructor and modifier categories will be discussed in a later video. An object is closely associated with the class it belongs to. An object has attributes as defined by its class. The object's behavior is restricted by the methods that are included within its class, like when your parents set rules and curfews for you. There are significant differences between objects and classes. A class is written by a programmer, cannot be altered during program execution, and is a blueprint that defines attributes and methods. On the other hand, an object must be an instance of some class, exists while a program executes, and must be declared and constructed by the program. Objects have attributes that can change, and methods that can execute during program execution. Finally, an object is often referenced using an identifier. Classes can be compared to blueprints, as I've done already. The purpose of a blueprint is to provide a guide to creating things, just as the purpose of a class is to guide the creation of objects. A single blueprint is designed to produce a single basic type of object. Similarly, the objects from the same class all share common characteristics. Each object must belong to one particular class, and the object is said to be a member of the class of which it belongs to. The pencil object belongs to the Drawing Tool class. This means that the pencil object is permitted to perform Drawing Tool methods. This also means that the pencil object is not permitted to perform Draw Square methods. These methods are designed for a different kind of object. So what were you supposed to learn in the last 13 minutes? Well, a programmer designs and writes classes that can later be used in other classes to create objects of the previous class. Then the objects work together to solve the problem. Also, breaking down a large problem into a collection of smaller problems is a very useful programming technique. When designing a class, we gotta consider behaviors and attributes of the objects created from that class, as well as how we'll create those new objects.